Hello, welcome to Physics 2212 Lab 1 Charge Tapes. So the goals of this experiment were to determine the interactions between a charged piece of tape and other objects, including a hand, a pen, and another piece of charged tape. And we also wanted to determine the excess charge of a single piece of tape and simulate all these interactions using Python, the computational model. And so previews for some of the results is that the charged tapes tended to repel each other, and the charged piece of tape ended up having a positive charge that was 2.24 times 10 to the negative 8 coulomb, and that each piece of tape was deficient of 1.4 times 10 to the 11 electrons. So there are a few key concepts for this lab. The first one is Newton's second law, which is the sum of the forces is equal to mass times acceleration, and this is used to find the gravitational force. And then there's the electric force, or Coulomb's law, which is that the electric force is related to the charges and the distance between them, as well as a constant. And then the superposition principle, which is that each charge creates its own electric field that's independent from the other charges. Some important assumptions in this lab is that both pieces of tape have the exact same amount of charge and that they're the same size. Each tape will act as a point charge located at the tape center. And the U-tapes will be modeled as singular point charges in the computational model. We're also ignoring air resistance. The system will be the tape, or the two tapes, whatever is interacting together, and the surroundings will be everything else in the room. And the initial conditions for the model will be the two neutrally charged pieces of tape have the same length, with an additional neutral piece of tape stuck to the table. To charge the tape, basically we measured out a base tape and a U-tape. The U-tape would be put over the base tape with a flap so that it could be easily pulled on and off the base tape, and this is how the tape was charged. And then to test the charge of the U-tape, we would place our hand next to it and see how they interacted. In our case, they were attracted to each other, and this tells us that the tape is positively charged. These are some photos from our experimental setup, and this is a video of the two U-tapes shown repelling each other and a diagram of the procedure for the two U-tapes, and then a free body diagram showing the tape represented as a point charge with the electric field in the positive direction and then the force of gravity in the negative direction. What we observed from the interactions between the tapes was that the two U-tapes repelled each other. The U-tape and the hand were attracted to each other, and the U-tape and the pen were attracted to each other. And this attraction is due to the negative charge of the pen, which results from rubbing the pen on clothing, which would give it the negative charge. And so our conclusion was that the U-tape is positively charged and has lost electrons through this charging process. For some initial measurements, the length of each tape was 0.2 meters, the width of the tape was 0.019 meters, the surface area was 0.034 meters squared, the distance between the two tapes was 0.048 meters, and acceleration of the tape due to gravity is negative 9.8 meters per second squared. Continuing the data and calculations from our free body diagram, we see that the force of gravity is equal to the negative electric force, and so we measure the gravitational force to be the acceleration due to gravity times the mass of the tape, and then the charge will be equal to the square root of the electric force times the distance between the two tapes squared times the constant, and then the electron deficiency will be a ratio between the charge of the tape and the charge of a single electron, and then the number of atoms can be calculated to be the surface area of the tape divided by the surface area of a single atom, and then the ratio we found to be 1 electron per 2.74 times 10 to the 6 atoms. Here is some screenshots from the Python code for the lab setup, and on the left you can see the two pieces of tape modeled as point charges. The one on the top is the blue dot, one on the bottom is the green dot, and so you can see the electric force is represented as the yellow arrow pointing upwards and the gravitational force as the red arrow pointing downwards, and then my code is on the right. There are a number of discrepancies and sources of error in our experiment. The tape cannot be truly represented by a point charge. It's much larger, of course, than a single point charge and would therefore exhibit different effects. It's unlikely that the two pieces of tape held the exact same charge. In fact, they were probably not even exactly the same length, and because of this, there's going to be some error in the charge measurement, and some of the charge was likely lost through the handling process, despite the fact that we tried to handle it as little as possible. And then the what if and why questions. What if the electron had a positive charge and protons had negative charge? Well, the charges would still behave the same, as in the like charges would still repel and opposite charges would still attract. So even if the sign of the charges is flipped, they will still behave the same. And why is it important to handle the charge tape as little as possible? This is to ensure that they remained as charged as possible to get the most accurate measurement, because when they're in contact with other objects, the tapes will begin to neutralize and, in this case, like gain back electrons, lose their charge.